This is going to be our final lesson on Chapter 17. Chapter 17, Lesson 3 on volumes of revolution. At the start of class we looked through the answers to 5a and 6a, so I put those there for you to check to see what mistakes you made, if any. One step that I put in at the end here, because I forgot to do this before, was to find out what the limits were for these questions. Now if you draw a picture, I think this makes it a lot easier. Certainly you can see that 0 is one of the limits. So if we set the two equations equal to each other and then solve, we can find out when this equals 0, 0 and 1, which I gave to you in the question. Now also when I do this, I always make sure what I put in parentheses for y and then square it. And the reason I do that really is for this question over here, because if I just write 4x and then put squared, it might just look like 4x squared. Whereas if I put it in parentheses, you can clearly see that it's all of 4x squared. So in other words, 16x squared. So I think that's always a good idea when you're doing these questions. Now for today's lesson we're going to be looking at volumes revolving around the y-axis. So I've got my graph drawn here. This is supposed to be a straight line. You can see the shaded area here, but this time it says it's rotated about the y-axis. So one thing we would need straight away is the formula for that, and from the previous lesson it's pi the integral of x squared dy. Now there's a couple of extra things with this question. With revolving around the y-axis, we have to look at the y limit. So on a previous question we probably would have said it was 0 to 4 looking at the picture. But that's because we're revolving around the x-axis. As we're revolving around the y-axis this time, we look at the y limits, so 0 and 1. Now also, we don't give an equation for this, so we need to figure out what this equation is. And if you look at this picture, you can see it's got a slope of rise of 1 run of 4. So you can see that the equation for this is y equals 1/4 x. Now I can't integrate this straight away because it said this has to be something in terms of y, and this is in terms of x. So we need to rearrange our equation to make it in terms of x. So if we multiply both sides by 4, then we would have 4y equals x. And then I can substitute in here, and that's actually what we can see when we look at our solution here. Oops. So I rearranged for x, and then I substituted into the equation that we had here. So pi times, I'm supposed to say 4y all squared, which gives you 16y squared. And then if you integrate 16y cubed over 3, increase the power by 1, divide by the new exponent. And then if you plug in those limits, then you should end up with 16 pi over 3. Now we did 5a, but I'm also going to go back to 5b, which is the same picture but revolved around the y-axis. Now from 5a we already found out the x limit for the intersection is going to be 0 and 1. Well, the y limit you can see is still 0. And when x is 1, if I plug that into either of these two formulas, then I get y is 1. So my limit for this one is going to be 0 and 1, the same. Same formula. I've got to rearrange both of these to make them say x equals. So one of them's trivial. If y equals x, obviously x equals y. And if y equals x squared, if I rearrange that, then I get x equals radical y. Now as it's two curves, we're going to use the f of x minus g of x. So the one that is furthest away from the y-axis is going to be this one here. So the one that's x squared I want to come first, and then the one that's closer to the axis I want to be my second equation. I'm not too worried about this because I know if I do it the wrong way around I'm just going to get a negative answer which I can ignore. So for each one, pi, take the x value and square it. So I'm going to do this one first. So pi square root of y squared minus, and then the second one, x equals y, and then square that. And then if we work out both of those things, then the rest of the question should actually be fairly easy to work out. Integrate, plug in the limits, and then solve. So pi over 6. So most of these steps you're actually familiar with. The main thing for today is making sure that you choose y limits instead of x limits, but also making sure that you solve for x so you can substitute into the formula. Now what I'm going to show you now I don't really mind too much if you don't understand, but there was a slightly shorter way I could do this question. As I'm trying to find what x squared is, I went ahead and found out what x was and then squared it. Really what I should be doing is solving for x squared directly. So for this first equation I actually know what x squared is. It tells me it's just y, so I can actually do straight away. Instead of putting pi x squared dy, I could put pi y dy. And if you go down to this step here, you'll notice actually that is what happened. So it seems kind of pointless square rooting it to find x, and then on the next step squaring it to get to y. So that's two unnecessary steps. So if you know what x squared is, go ahead and substitute for that directly. If you don't, solve for x, and then just simply square it like it says in the formula. The questions that we did in class today, I believe are featured right at the bottom here. So we looked at exercise 17, 6b and 7b to finish off those questions from last time, or the second parts of those, and then miscellaneous 17, 1, 4 and 6. Now, one thing that people did have problems with on some of these questions is they've forgotten what happens when we have the infinite integral, or if we have something like this. So if we do infinity squared, infinity plus 3, infinity minus 3, all those things are going to give us an answer of infinity. Now if we were to have something like y over x when we plug in, then 1 divided by infinity is going to be 0. The way we originally checked this in class, we did 1 divided by 9999999, or in other words a very large number. And what you found out was it came out as 0.00000. So basically it's 0. The other thing that people made mistakes on was on question 1. I think try and draw a picture for this question, and I think that will certainly help you. I'm not going to show you what the limits are for that question, but a lot of people, when they did the y squared part for this one, they ended up with this, and then they just said, oh, I square this one, and then I square this one. So they put x to the 4th plus 1, when squared actually means you're going to multiply by itself. So go ahead and do FOIL, and then go ahead and integrate. So keep an eye out for those few problems as well to help you answer the homework questions.